mission to a mysterious metal asteroid. Welcome, and thank you for joining us live from the Space Coast of Florida for the first of its kind mission. I'm NASA's Megan Cruz, and this is Jim Bell, a professor at Arizona State University. Great to have you here.
Spectacular, great, good morning. Launch day, launch day, launch day, super exciting.
You have a lot of excitement, and I'm glad to see it.
Yes.
As he said, launch day, so liftoff is targeted for exactly 10:19 and 43 seconds Eastern Time. The name Psyche refers to the spacecraft we're launching today, but also the asteroid we're sending the spacecraft to. And we actually have a model of the asteroid right here, a very baby model.
Tiny model, right?
A lot smaller than the real thing.
Yes, the real asteroid is about as wide as the state of Massachusetts, so it is a very, very large asteroid. It was discovered in 1852 by an Italian astronomer, and he named it Psyche after the Greek goddess of the soul.
Beautiful name.
Yeah, so because of that, we named our spacecraft Psyche. And because of that, we named our mission Psyche. So the focus is on Psyche, Psyche, Psyche.
Yep.
We're really focusing on really getting to know this little world.
All makes sense to me, easy to remember.
Yes.
So
Exactly.
as you place that asteroid down, tell me where Psyche is in relation to us and our solar system.
Right, well, you remember elementary school, right? Mercury, Venus, Earth, Mars, Jupiter, right? And between Mars and Jupiter is the main asteroid belt. And this asteroid orbits in the main asteroid belt between Mars and Jupiter about 3 times as far from the sun as the Earth.
And really quick, a very unique asteroid, obviously, metal rich.
It's metal rich, and it's the largest one of its kind in the entire solar system.
And that's why we're going to.
Yes.
And there is a lot to learn about this mission. That's why Jim and I aren't the only ones you'll hear from today. We have Jasmine Hopkins here at Kennedy Space Center at a nearby viewing location, Raquel Villanueva at NASA's Jet Propulsion Laboratory in California, and Daryl Nail and Mick Woltman, who will walk us through the operational milestones today. All right, so guys, SpaceX has been fueling its Falcon Heavy rocket for about a couple of minutes now. And the other watch item is, of course, the weather today, but we are looking a lot better than yesterday.
Yes, we certainly are, Megan and Jim, and good morning to you both who are looking lovely in your purple and orange mission colors. Mick and I here, we're in our gray, which was the weather yesterday, but, you know, great news in terms of the weather for today's launch. It improved to 85% go. We just heard a weather brief as she gave that brief to the launch director, Mike Taylor of SpaceX, and you can see it on the graphic there. 85% go. Winds are light and variable, 5 to 10 miles per hour out of the west. Temperature 82 degrees, and of course it's humid. Our only concern, though, Mick, a potential cumulus cloud in the area. We don't have any rain, as you can see on the radar. That's the best news that we got today.
Yeah, absolutely. Like Jim, I'm excited this morning. I mean, we started early this morning, Daryl, you and I listening to the nets, and the weather has only improved over the last several hours down to this 85% go, and I'm excited for that as we move into launch liftoff this morning. The range team will continue looking at the weather and along with the engineering team on the launch vehicle, but things are looking really good this morning from a weather standpoint for this mission. I'm very excited.
The other major factor for consideration before launch is the range. As you look at a beautiful shot orbiting around the launch pad there at Launch Complex 39A, the Falcon Heavy, the 3 boosters at the bottom, and the spacecraft Psyche encapsulated at the top. That range, as you can get a look around over the Atlantic Ocean, is green, so we're good to go there. Listen now.
NY, PY, and Center Core LOX load has started.
That is the call out for LOX load. So now we were flowing RP1 propellants into the Falcon Heavy boosters, those 3 boosters at the bottom. Now we are flowing LOX, which is more of a delicate operation.
Yeah, absolutely. About 5 minutes ago, we started the RP1 load, which got the fuel going into the boosters, and now we are putting the cryogenic densified LOX in board. Between the 2 propellants, that will provide all the fuel and energy needed to fire the 27 Merlin engines this morning. So the team is loading the first stage, and about 5 minutes from now, we'll start loading second stage. So things are looking really good, and nominal instrumentation on all the load.
We are counting down to a T0 at 10:19:43 a.m. Eastern Time, 14:19:43 UTC time. It is an instantaneous window now that we've started LOX. Real quickly, Mick.
Yeah, absolutely. We starting this densified LOX, it sets our window for this morning because we've committed to that because we have to maintain that cold temperature of the densified LOX in the stage. So the team is confident. They've given the go. We've started propellant loading, and we're looking forward to liftoff.
All right, our next call out will be for propellant load in the second stage of the rocket. That's coming up in just about 10 minutes. But for now, we'll send it back to Megan and Jim.
Wow, what do you think of those live views from the helicopter?
Daryl and Mick are awesome too. It's great to have these experts.
We're awesome too. Yeah, it was really great to see those shots, not, of course, of the rocket, but also the weather. 85% go.
It's been our biggest concern, right? The spacecraft is ready, the rocket is ready, the team is ready. Let's hold out for the weather.
Yeah.
It's looking good.
Looking good, exactly. Now, you heard that call out over the loops about loading liquid oxygen. You're going to hear call outs like that throughout the broadcast, and we're going to pause for those so that you can follow along with operations. Our broadcast today will take us all the way through the moment we deploy and get the first possible signal from the Psyche spacecraft. Now, Jim, people might be wondering why go to a metal-rich asteroid?
Well, we've visited over 60 or more years of NASA and other space agencies. We've visited gas planets and rocky planets and icy moons and comets and rocky asteroids. We've never seen a metallic asteroid. There's a big population of them out there. Psyche is the largest one.
Right.
So we want to study this class of objects that we've never seen up close in the solar system.
And so what do we hope to learn by studying Psyche?
So one hypothesis is that Psyche might be the preserved ancient core of a little planet, a planetesimal. And so we can't study the core of the Earth, right? It's too hot pressure's too high. We can't study the core of the moon or Mars or anything else like that. So here's a chance to study the core of a growing planet from early in the solar system that is exposed to view. At least that's our hypothesis, and we want to test that with our instruments and our amazing spacecraft.
Perfect. And actually, speaking of the spacecraft, Psyche isn't the only experiment flying today. Hitching a ride on the Psyche spacecraft is the Deep Space Optical Communications Experiment, or DSOC. So, Jim, this is a completely separate technology demonstration.
Yeah, so we're used to radio communications with spacecraft, NASA's Deep Space Network. This will be the first time we'll use optical laser beam communication to try to talk to the spacecraft as it goes farther and farther out into the solar system. And that technology has been demonstrated out to the moon, but not beyond. So we want to use it out at Mars and get much better data rates, much higher quality data. So it's going to be a great test, and Psyche mission's just super happy to be carrying the DSOC.
Yeah, a lot of science packed into one mission. Now, Jim is obviously very knowledgeable. That's why we're inviting you to send him your questions about the mission. So just submit them online using hashtag AskNASA, then watch as we answer your questions live. And you can also interact with us by playing Psyche Bingo. Jim is ready to show you the card that you can get. You can get your very own by scanning the QR code we're about to bring up on your screen here. And every time you hear a bingo word on the broadcast, so for example, we have cruise, iron, core, Mars, whenever you hear one of those words, just mark it on your card. And when you get bingo, you can show off your win on social media by tagging @NASA Solar System.
Right.
Now, Psyche the asteroid is sometimes called 16 Psyche, and that's because it was the 16th asteroid to ever be discovered. Now, more than 160 years later, scientists will soon study it up close.
16 Psyche is an asteroid that orbits the sun out between Mars and Jupiter.
The reason that Psyche is unique is that it is metal rich.
It's believed that it may be a remnant core of an early planetesimal that was formed in the very, very earliest parts of the formation of the solar system.
And after this planet started forming and this metal core formed inside of that, it collided with other bodies that then stripped off the rocky mantle, leaving this core in place.
This is the part of planets that we can't sample directly today.
It's too hot, the pressure's too high, our instruments would melt. Can't drill a hole that deep in the Earth or other planets. So how do we study the core of our planet?
Psyche gives us the opportunity to visit a core, the only way that humankind can ever do, and it would be the first metal object that humankind has ever visited.
After launch, we cruise through interplanetary space for a number of years. First, we fly by Mars for gravity assist that'll slingshot us into the asteroid belt. And then we're thrusting all the way from there to finally arriving at Psyche.
We'll go into 4 orbits to collect the necessary measurements that we need from our 3 primary instruments.
So our payload consists of a couple of imagers, which are cameras that take pictures of Psyche. Also a gamma-ray neutron spectrometer, which allows us to measure the elemental composition of the surface of Psyche. And then a magnetometer, which will allow us to detect any magnetic field that's left at Psyche.
If Psyche still has some sort of remnant magnetic field, that probably tells us it really was a core. It's a strong indicator. We also use the radio on the spacecraft as an instrument, so we can map out the gravity and map out the interior structure that way.
We're using a particular thruster technology, Hall effect thruster technology. They operate 5 times more efficiently than normal rockets, so they use a lot less fuel, and is what allows us to get into orbit around this asteroid.
Solar electric propulsion has been around for quite a while, and it has flown before, but we're continuing to push the boundaries. We're going to have big 5-panel fold-out solar panels that will provide the electricity for the thrusters, which use as propellant the noble gas xenon.
This will be the first time that Hall effect thrusters have flown in deep space.
Studying the evolution of a planetary body is a detective story.
There's a magic to when you actually are on the launch pad and you say, we're go for launch.
And you feel like singing and dancing, and you feel like throwing up at the same time.
Let's go discover things about our solar system that we have no other way to do. I think that it's fundamental to who we are and also who we should be. It's an incredible opportunity to be a part of the team making that happen.
I want to take a second to repeat what you just said in that video, feeling like throwing up and excited and dancing all at the same time. Is that how you're feeling right now?
Butterflies right now, very excited, but also super confident. This team is amazing that's putting this show together for us. So.
And the scientist leading the investigation, we just saw her in that video, Lindy Elkins-Tanton. She's a professor at Arizona State University, where you also work, and you are also the Psyche imaging lead. Talk to us about that.
Yeah, so we are running the camera investigation on campus at Arizona State. We designed, built, and tested the cameras. It's a collaboration between Arizona State University, our partner Mail and Space Science Systems in San Diego, and of course JPL, our colleagues at JPL. And we have a staff of faculty, staff, and students at Arizona State, and we'll be running the Science Data Center there for all the instrument data to flow through, including the imagers. So we'll be taking those shots, putting the mosaics together, getting them out to the public as quickly as we can.
I love that students are also involved.
Yeah.
Okay, T-minus 36 minutes and 12 seconds until liftoff of the Falcon Heavy rocket and Psyche spacecraft. Let's check back in with Daryl and Mick.
Megan and Jim, we are still green for weather and range, which is great news as you look at an orbiting shot there of the launch pad. We're here at Hangar AE at the Mission Directors Center. A lot of high-level folks behind us monitoring the mission, keeping track every step of the way. Mick, you did hear something, though, on the Range Ops Net that suggested that we had a recreational boat not in the box, which is the area of concern when the rocket goes up, but near the box. Nonetheless, they're going to get a visit from a Coast Guard cutter.
Yeah, absolutely. Being here, Launch Complex 39A, right here on the coast of Florida, you know, we have all kinds of things we have to look at, all kinds of weather constraints. We talked about the weather this morning. We have launch vehicle constraints you have to worry about, and we have range op constraints that have to be met. So the range team from the Space Force is monitoring all that and looking at it, and this is just one of those things we have to deal with.
We're also watching propellant load, the big operation as we lead up to the liftoff today, and in just a few seconds we're going to start RP1 load of the second stage. Let's listen in.
Stage 2 RP1 load has started.
With that call out, we're now loading the second stage with propellant, and following that we'll LOX load it. But the long pole in the tent are those 3 boosters that we're looking at.
Yeah, absolutely. We're about halfway filled with the RP1 and the boosters there as we look at the data on the screen, and LOX is continuing to flow in all 3 boosters to make sure everything's filled this morning for propellant. And second stage has started also. We're very excited to get all this propellant done. This is the most critical and long portion of the operation to get this vehicle tanked and ready for liftoff.
Very good. And the rocket standing tall today with a Psyche spacecraft encapsulated at the very top. A beautiful shot here on the Space Coast. The weather improving to 85% go. The Falcon Heavy with its 3 boosters going to lift that portion of the rocket that you see right there Psyche is encapsulated inside, roughly the size of a van, inside that fairing, which protects it from the atmosphere.
Yeah, during ascent, we have to protect the spacecraft through all the Earth atmosphere, and as we get heading into space. And once we get into space, the fairing will be deployed, and Psyche will be out in the environment and ready for deployment.
And SpaceX planning on capturing those fairings today after they fall back into the ocean. Coming up, we're going to load the last of the commodities, LOX, into the stage 2. Stay tuned for that. For now, we'll send it back to Megan and Jim.
Okay, so that's what's going on with the launch vehicle. Now it's time to check on the Psyche spacecraft itself. For that, let's go to NASA's Jet Propulsion Laboratory in California. Raquel, so JPL is managing this mission.
That is correct, Megan. This is the Psyche mission support area behind me, where about 36 people are working. These are experts in operating the spacecraft. The team had a very early start on the West Coast. Many of them arrived around 3 o'clock this morning to start preparing for launch. Around this time, engineers have to turn on power to the spacecraft. And that's what they're doing here, transitioning to internal power using the battery that's built into the spacecraft. This battery is used until Psyche can get solar power when the solar arrays deploy. The team is also equipped with Lucky Peanuts. Eating them before major mission events is a tradition here at JPL. As we get closer to launch, I will talk to team members gearing up to take their seats in the mission support area you see over here. Back to you, Megan.
32 minutes and 3 seconds and counting to launch here at Kennedy Space Center in Florida. People from all over the world visit KSC on launch days to be part of such an epic sight. NASA's Jasmine Hopkins is live at one of those viewing areas now. Jasmine.
Thank you, Megan. Yes, we are on the balcony of the Operations Support Building 2 here at Kennedy, where we'll have a great view of the launch over in the distance. And joining us now is the Deputy PI for Psyche, Ben Weiss. Thank you so much for being here.
Super excited to be here.
Of course, I'm sure you are excited. You've worked on this mission for over a decade. So tell us how your journey started at MIT and how that got you here.
So we have a laboratory in which we measure the magnetism of rocks. And back in 2010, we were finding many meteorites, for some reason, were very strongly magnetized. They formed an ancient magnetic field billions of years ago. We were really perplexed, like what could be the origin of this magnetic field? And we were puzzling over this, and one day, Lindy Elkins-Tanton, the future PI of Psyche, was walking by my office, and I asked her, do you have any ideas about what this magnetic field could be? And she's like, I was just teaching a class about this topic right across the hall from you. So she came into my office, we talked about it for an hour, drew a bunch of things on the board, and then by the end of it, we came to the conclusion that many of these meteorites came from asteroids that had formed little metallic cores, just like what's in the center of the Earth. And the churning of these molten metallic cores generated a magnetic field just the way the Earth does. Okay, so we wrote a paper about this. Some scientists at JPL read the paper, and they invited us, also Maria Zuber was involved with that, and invited us out to JPL to see whether we might want to build a mission associated with this. And we thought about this for a second, like, yes. So then we went out there, and here we are 12 years later.
Right, it's great to see how you got here. So you're also speaking of this magnetization, and you worked on the magnetometer. You're the lead for that instrument. Can you tell us, how will that role expand after launch today?
So we've been, until now, measuring little quarter-millimeter fragments in our laboratory. Now we're sending a magnetometer out on a big spacecraft out to measure the magnetic field of a big asteroid. And we're hoping to make the first detection of a magnetic field around an asteroid.
Right. And Ben, as you said earlier, you have been working on this 12 years, so it's great to see that you are here today for this launch.
Surreal.
Of course. Thank you so much, Ben Weiss.
Thank you.
Back to you.
Now, we just heard from Ben, Psyche's magnetometer lead. Why don't you tell us about what a magnetometer is? Why don't you break that down for us?
Megan, this is not just the host desk. This is the host desk of science. Because we're going to do a little demo here.
Love
This is the magnetometer.
Okay. So think of this as this magnet as a magnetometer.
That magnet is the magnetometer. I have 3 rocks here.
Okay.
This is a rock from my backyard, and these are 2 rocks from space. These are 2 meteorites from the ASU Busek Center for Meteorite Studies, and I would like you to be the magnetometer. The Psyche magnetometer approaching this particular rock, which is a piece of granite. It's from my backyard in Arizona. Don't just take it for granted. It really is a piece of granite. Yep. Okay, so not magnetic, right? Not much iron in that one. Now try this one. This is a so-called ordinary chondrite meteorite. It's a little magnetic. It's kind of not it's sticking a little bit, has a little bit of iron and nickel in it. It's kind of like the material you'd find. This would be crustal material, crustal and mantle kind of material.
Okay.
Now try that meteorite.
Whoa.
Yes,
oh my gosh.
right. This is an iron, it's like massively stuck on there. This is an iron meteorite. This is part of the Canyon Diablo meteorite, which created Meteor Crater in northern Arizona.
Okay.
So you saw how strong that magnetic field is on this one, and so we'll be using the magnetometer on the spacecraft to try to detect that kind of magnetic field. And if we see that strong magnetic field, it is a good indicator that Psyche is an ancient core.
Okay, so that's what we want to do. We want to take this magnetometer, orbit the asteroid to see if there's that magnetic field. And so if we discover that, yes, this is likely a planetary core, what does that mean for us?
Well,
what can we learn from that?
It gives us an opportunity to study a core of a planet in a way we just can't. We can't go to the Earth's core. We can't study the other planetary cores. But here we can look at this object, which we can get its chemistry, we can look at the kinds of minerals on its surface, its geology, its density, its gravity field, and really understand some details about how cores form and therefore how planets form.
How planets form, our planet.
Our planet in particular.
Okay,
exactly,
thank you so much for breaking this down. Love the demo. Managing today's launch is NASA's Launch Services Program based here at KSC. It's responsible for delivering uncrewed spacecraft like weather satellites, telescopes. Many of those end up orbiting the Earth, but Psyche is going to go much farther. NASA's Daryl Nail spoke to an analyst about Psyche's unique trajectory into deep space.
Jermaine Oliver, good to see you again.
How you doing?
Well, this is your animation here. You're the LSP trajectory analyst. Show us now what is happening here with the second stage and the Psyche spacecraft on board.
We have the second stage and the launch vehicle together, and we're going through our first burn. This burn is going to get us to park orbit. During park orbit, we will basically loiter there until the trajectory lines up to get us on an outbound cruise to Psyche.
Okay, and so now you're going into that park orbit, and I notice this thing's moving around a little bit.
Well, we want to keep the sun about a 90-degree angle, but at the same time, we're doing what we call a barbecue roll, where the spacecraft will just spin to keep the temperature gradient across the spacecraft and the launch vehicle the same. You don't want the sun focusing on one particular area that could potentially damage any instruments or any hardware.
So it is continuing on the velocity vector, which we see here very clearly, and that 90 degrees to the sun. This is a long coast phase.
Yeah, about 45 minutes or so before we actually get into the injection burn.
Is there anything happening during this coast phase?
No, we're just pretty much just going through the barbecue roll, tracking the sun, keeping it 90 degrees away.
We're approaching now southern Africa and crossing that continent, but then getting ready for that second burn.
Right. When we finish crossing over the continent of Africa, then we'll start getting ready to do that injection burn where the vehicle will get into another attitude that will line up with the velocity vector.
And is that why we're seeing it start to swing back around?
Yes, you're starting to see that swing a little bit slowly right now.
Now the sun is on the other side of the Earth and starting to get into a shadow, so we'll actually be in darkness here as we approach the northwestern coast of Australia.
Correct. But that's not a concern to us. We're still going to maintain the barbecue roll, as you can see. And as you can see right now, we're actually lining up to get to that velocity vector. And once we line up with that, we'll perform that injection burn.
All right, we see it now in the dark side of the Earth, starting to point into that velocity vector that you mentioned. And here comes our second burn.
Yes. You're about to see the second burn happen right now. It's about 2.5 minutes. This will inject us into the orbit that we will need to get to Psyche.
Second engine start, number 2. Your animation has a little vibration there as the engine's giving it the go, and then it cuts off.
Yes. And now, after this burn is complete, we will then get ready to go to the separation attitude. So you see the launch vehicle and the spacecraft get into an attitude where when we separate the spacecraft, the launch vehicle can then go into another attitude and perform a burn to get it away from Psyche.
I see it swinging back around, and here you've labeled Psyche separation.
Yes.
This is the moment where the second stage comes off the spacecraft.
Yes. At this time, we have separated from Psyche. Psyche is on its way. The launch vehicle is now performing a burn to get itself away from Psyche to include recontact, and Psyche will be on its way shortly.
Great. We don't want to run into the second stage with the spacecraft. It's got a job to do. And first, it's going out towards Mars.
Yes, it's going to do a Mars flyby to get that gravity assist, to slingshot itself over to the Psyche asteroid.
Help save fuel, get out to its destination. That's all a good thing.
Yes, sir.
Jermaine, thanks for showing us that.
Thanks for having me.
Time.
And we have space enthusiasts watching today's launch from around the world. And we have some recorded questions that they've sent in, while some are posting them live to social media. So why don't we get to some of those questions now?
Let's do it.
Don't be nervous. I think you'll get them all.
All right.
So here's the first one.
Hi, I'm Ezra, and I have 2 questions for you. How will you communicate with the spacecraft, and how did you come across Psyche 16? Thank you.
Oh,
Wow.
great first question.
Ezra's awesome. Those are great questions. So we actually communicate with the spacecraft using radio waves. So the spacecraft has a transmitter and a receiver, and it talks to NASA's Deep Space Network radio telescopes, which are around the world, in California, in Spain, in Australia. And these are enormous radio telescopes that can detect even very faint signals because we're going to be very far away. So we send radio signals back and forth from the ground. We send the signals up, giving the spacecraft the commands what to point at and how to thrust. And then the spacecraft sends its data back down, telemetry, the pictures we're going to take, the data from the magnetometer and the other instruments. So it's all through radio. And his second question, how did we come across Psyche 16, was it was discovered by telescopes back in 1852.
Wow.
And it was the 16th asteroid that astronomers discovered.
Perfect. Can't believe so long ago, right?
Yeah.
Okay, let's take another question from social. Do we have a certain hypothesis as to what chemical elements or metals are present in the metal asteroid?
We do. We have a number of hypotheses because that's what scientists do. We pose hypotheses and then we test them. And one of our favorite hypotheses is that Psyche, the asteroid, is a lot like that metal meteorite that I showed you. It has a lot of iron and nickel and other heavy metal elements, and maybe a little bit of silicate rock on the outside from impacts into Psyche over time. But we're really going to be especially looking for that iron and nickel to try to make that case that it's a planetary core.
Hypothesis now, but you guys are going to soon prove it right
Test.
or figure out something else, huh?
Exactly.
All right, great questions, guys. Keep them coming, again, using hashtag AskNASA. Now, launching Psyche today is part of what NASA is calling Asteroid Autumn. The agency is conducting a lot of science on different kinds of asteroids around our solar system. So let's learn more about that with NASA's Jasmine Hopkins.
Thank you, Megan. Joining us now is NASA Administrator Bill Nelson. Thank you for being here.
Great day.
Yes, it's a great day to launch. So you were just in Houston, NASA's Johnson Space Center, for the unveiling of the OSIRIS-REx sample return mission. So tell us about that. I mean, we are now about to launch Psyche. So why are we conducting these ambitious asteroid missions?
Isn't it interesting that asteroids are just fascinating to us because it gives us the clues to the origins not only of our solar system, but also the universe. So we brought back OSIRIS-REx. We revealed it yesterday at the Johnson Space Center, and lo and behold, it has water in clay. And this is just on the outside of the container. We haven't even opened the container yet. It also has carbon. So if you got water and carbon, you got the building blocks of life. Now, this one, Psyche, we're going to a metallic asteroid, which is a core of some kind of celestial body. And as a result, we're going to learn all kind of new things, how these things fly through the solar system and they hit each other and they cause the evolution of what we have today, our solar system.
And Administrator Nelson, you know, we're also looking at the longevity of a mission like Psyche. It's going to take us about 6 years to get there. So what are the long-term effects of a mission like this?
RP1 load is complete.
Well, it's what you have to do to get there. We're using a flyby Mars as a gravity assist, and that just takes longer to get there. But isn't that something? That 6 years down the road, we're finally going to get the revelation of what we're looking for, but we had to start planning it and building it even several years before this.
Right, exactly. It's great to see that we are here on this day for launch. Thank you so much for joining us, Administrator Nelson. Jim and Megan, back to you.
I mean, just heard that call out for stage 1 RP loading. Okay, we're coming up on another major fueling milestone now. Let's check back in with Daryl and Mick.
That's right, Megan. Stage 1 RP load complete, and so that completes the stage 2, rather.
Stage 2.
Complete. But we're continuing to load RP1 in the first stage boosters as well as LOX, which is the long pole in the tent. And as we look at this view from our Kennedy Flight Operations team and their Airbus H-135 helicopters, which are out there for security purposes, and they have a camera on board, thankfully for us, you can see the LOX clouds surrounding the rocket, which it's quite a humid day here in Florida today, Mick, so it really stands out dramatically.
Yeah, that cloud is caused from that boil off we talked about, Daryl, that once we start loading, that cold locks into the vehicle. We get boil off that occurs to allow the venting of the tanks so that we can get as much LOX into the tank as possible for today's mission. We want all of that propellant to be able to get Psyche on its way on that trajectory that Charmaine talked to you about.
Speaking of LOX, we are getting ready to start loading LOX into stage 2 of the rocket, the upper part. And you can see that
Stage 2 LOX load has started.
There's the call out. You can see that the strongback has been chilled as well. Now LOX is flowing up to the second stage of the rocket.
Yeah, now this will be the last and final propellant we need to get on board the Falcon Heavy this morning. We continue to load RP1 and LOX onto the first stage, and now that we've started stage 2 LOX, everything will be complete. Daryl, I did want to say Jim is excited to be answering the questions of those kids today. Me personally here in Brevard, I got Miss Stafford's class watching you and I today out at Saturn Elementary, and they're excited to be watching what we're doing.
Well, we thank them and all students who are tuning in today. We are hoping to have a liftoff here, and everything looks good for a T0 at 10:19 and 43 seconds a.m. Eastern Time, 14:19:43 UTC time. We will continue to track the tanking of this rocket, and we'll be back at T-minus 8 minutes to count down to liftoff. In the meantime, we'll send it back to Megan and Jim.
Now, once the Psyche spacecraft is deployed today, it's going to take 6 years to arrive at the Psyche asteroid. Why is that? Why so long?
Space is big, right? We live in a big solar system, and it takes a long time to travel between planets. 3 days to the moon, 6 months to a year to get to Mars or more. And so we are going on this looping trajectory from the Earth all the way out to Mars. We have to pass by Mars and get a little gravity boost from Mars. But then from there, we need to keep going out into the main asteroid belt, not all the way to Jupiter, but to about 3 times as far that the Earth is from the sun. And so it is just a long voyage, and it takes a long time to get there.
Yeah, and when the spacecraft gets there, it's going to observe the asteroid from different orbits, right?
Yes, so we will, you know, this is a model of Psyche. We don't know that the asteroid really looks like this. We don't know it's exactly this size. We don't know its mass to great accuracy, right? So we're going to very cautiously approach it and get captured in its gravity in a very high orbit that's something like 33 hours long, and really start to characterize it, get to know the place. Hey, look, we're here. Let's get to know the place, right? And then over time, we'll slowly lower that orbit, and eventually we'll be down in an orbit that takes only about 4 hours to go around the asteroid, and that's when we'll get our highest resolution data and all that chemistry data that we're talking about, and we'll be mapping the magnetic field and the gravity field the whole time. So yeah, that's why it's going to take us a couple of years, 26 months, to do that primary mission.
Yeah, a long journey for a lot of science.
Yeah.
Now let's get to another update from Raquel, who's live with JPL in California.
Thanks, Megan. I am in the Space Flight Operations Facility here at JPL, which operates the Deep Space Network. It consists of 3 complexes with large radio dishes that let us communicate with spacecraft that go beyond the moon. Now, these 3 complexes are strategically located in California, Spain, and Australia. They provide two-way communication and also help us track and navigate the spacecraft so we can keep them on course. And right now, the Deep Space Network is supporting over 40 missions. The Psyche spacecraft is expected to first communicate with the radio antennas in Canberra, Australia. Then data will come here to JPL. The operations team will use it to track Psyche, monitor its health, and send commands as it travels to the metal-rich asteroid. Megan, back to you.
Now, riding along with Psyche is NASA's first demonstration of deep space laser communications. Let's bring back NASA's Jasmine Hopkins to learn more.
Thank you, Megan. Yes, joining me now is Jason Mitchell and Trudy Cordes to talk to us more about the deep space optical communications, also known as DSOC. So, Jason, how exactly do these laser communications work?
Well, Jasmine, so just like on Earth, where space users are voracious for data, and so most of that data on Earth is routed through fiber optic cables with lasers, as everybody knows. We do the same thing for space users in this concept for things like DSOC, except can't tether a spacecraft to a fiber, so you have to do a free space link. And with that, there's at least 3 challenges. There's pointing becomes a challenge. You have to point very precisely. Plus, the Earth distorts optical light, right? And so you think about a hot road or the horizon of a hot road on a hot day, right? Like today, and you see that shimmer. And then 3, the signal is so faint, you literally have to count photons. So we have to have these super cooled nanowire detectors that are cooled to just about 1 degree Celsius above absolute zero. But you put that together and we get a capability to deliver data 10 to 100 times faster.
Right, so what we're doing is pretty complex. And Trudy, your directorate focuses on future technology. So how can we use DSOC in the future?
Right, Jasmine. So as Jason said, 10 to 100 times more data we're getting back. So it's very enhancing. For our friends in science, more data means more discoveries. And then certainly with all the work the agency is doing around Moon to Mars objectives, DSOC now gets into the to Mars part of that. So humans to Mars, a very realistic type of system we could use for reliable infrastructure such as advanced communication systems is absolutely enabling and going to make humans to Mars and exploration a possibility.
Exactly. I'm glad you mentioned to Mars. Jason, you are understanding DSOC on a deep level, and actually there will be something called O20 on Orion for Artemis 2. So how are they working in tandem?
So thank you. So the optical to Orion will be another optical demonstration on that vehicle, and it will. So they're different missions, so they're different implementations, but they do share a lot of common hardware, and they will use the same high-efficiency photon algorithms, right? Remember that photon-starved channel, got to count those photons. And that's how we'll accomplish that in injection or infusion into human spaceflight.
Right.
And Jasmine, just to add on, so Jason and I had the unique opportunity to go over and see O20 installed on the Artemis 2 service module yesterday. It looks absolutely beautiful. We're excited about that. We're very grateful to our friends in exploration for flying that for us to get this to an operational capability. And Jason knows what we like to say in space tech all the time. What do we say, Jason?
Technology drives exploration.
Bingo, exactly what Jason said.
Awesome. Great things to look forward to in the future. Jason, Trudy, thank you so much. Megan, back to you.
As you heard, laser communications will play a big role in our next mission to the moon. Let's see what else is already happening for Artemis 2.
It's a short package,
You would have thought it was launch day here at Kennedy Space Center just a few weeks ago. The Artemis 2 crew suited up in the historic Neil Armstrong Operations and Checkout Building. A test to practice a bit of what would happen before they lift off for the moon. Once their suits were on, they were off inside their brand new, fully electric crew transportation vehicles for the 9-mile drive to Launch Pad 39B. Kennedy employees waving to the crew as they drove by. At the pad, Commander Reed Weissman, pilot Victor Glover, and mission specialists Christina Cook and Jeremy Hansen took elevators to the top of the mobile launcher.
When we walked out that crew access arm, I just had images of all those Apollo launches and shuttle launches that I saw as a kid, and it was unreal. I actually had to stop and just stand a moment in the crew access arm to really let it all sink in.
The day's successful test ended in the White Room, their final stop before boarding the Orion capsule to the moon. That's your Artemis Moon Minute. If you're just joining us, welcome to live coverage of Psyche. Liftoff aboard a SpaceX Falcon Heavy rocket is now just 10 minutes, 13 seconds away. Atop in the payload fairing is the Psyche spacecraft, which weighs just about 6,000 pounds when fueled. That's about as heavy as a large SUV. It's made up of a body and 2 solar arrays in a cross formation, and when those solar arrays are extended, the spacecraft measures about 81 feet, or the size of a tennis court. It will be propelled by solar electric propulsion and will travel about 2.2 billion miles to study the metal-rich asteroid, also named Psyche. Now, Jim, you are one of the scientists behind this mission, a mission more than 10 years in the making. How are you feeling now with 9 minutes and 30 seconds to go before launch?
Oh, my goodness. I have butterflies the size of pterodactyls in my stomach right now. But really, I'm thinking about the team.
Yeah.
Right? I'm thinking about the hundreds, the thousands of people around the world, across the country, around the world, who have worked so hard to get to this point. Launch is the focus of big team effort. And I know there's lots of folks out there on pins and needles right now.
Absolutely.
But also, I think we're also just super confident in the team at SpaceX, the team here at Kennedy, to get us up there into space and give us a great ride.
Yeah, and this mission could benefit planetary science for generations. So impactful.
Absolutely. I mean, we won't get to Psyche till early 2029, right? So you think about a lot of the kids watching at home today or in school today, they're going to be the researchers who start working with the data in the 2030s and beyond. And we're going to have that data set coming in for a couple of years and hopefully learn a lot about planetary cores, the Earth's core, how planets form, and all kinds of cool things like that.
Jim, I really can't wait to see what you all uncover. Yes. You can't wait either.
I can't wait either.
Pterodactyls in your stomach. That must feel awful. And now taking us through the rest of the launch countdown are Daryl and Mick.
Thank you, Jim and Megan. Appreciate all the knowledge we are getting about the Psyche
Center
mission
core
today.
RP1 load is complete.
And there we just heard a call out that the RP1 load is complete, and that's great news. We're continuing to watch as this vehicle is tanked with propellants, 2.8 million pounds of propellants, both liquid oxygen and refined kerosene, called RP1. We've got a number of things that we are going to be looking at as we count down in the final minutes, Mick, and one of them is chilling the booster engines, transitioning the power to internal from shore power on the ground to internal to the rocket and the spacecraft.
Yeah, absolutely. As we're tanking the launch vehicle, there's also things going on with the spacecraft, and the spacecraft team is working all of their ops, transitioning to internal power, getting ready for this morning's launch. And we just heard that they confirmed communication with the spacecraft after a short transition, and we'll verify that they're on internal power here shortly. But things continue to look nominal for this morning's launch attempt.
And we're hearing, as we go along, updates about when each booster's RP1 is complete. And we will also hear when their LOX is complete. We're getting now down to the final filling of the boosters.
Engine chill has started.
Another key milestone is to pre-chill those engines. And that's critical when you're flowing super chilled liquid oxygen into them.
Yeah, we want to make sure all 27 engines are chilled to the right temperature, making sure once we get the chilled down RP1 and the densified liquid oxygen in there that things continue to work nominal from that aspect. So the team will continue to top off the LOX tanks and get ready for moving into terminal count.
We're getting ready to transition to internal power, both for the spacecraft and the rocket. That's coming up in just 20 seconds. We're watching the boosters as they fill. They are close to getting complete.
NY RP1 load is complete.
Another booster down for RP1. Actually 3 now. So now we move to the filling of the LOX and the completion for all 3 first stage boosters.
Okay, and I'm good to run that now.
Listening in for the switch to internal power. Beautiful shot of the rocket, Falcon Heavy.
Spacecraft is on internal power.
There's the confirmation. The spacecraft is now on internal power. The Psyche spacecraft that you see there encapsulated between those 2 fairing halves.
Vehicle tanks are pressing for strong back retract.
So there we heard the team is pressing the strong back to get ready to retract the transporter erector, or strong back as you refer to it, away from the vehicle just prior to launch. We saw a shot there at the fairing, and that structure will move here in about 10 seconds as they retract that. Things are continuing to move pretty quickly here, Daryl, as the team preps for a T0.
Strong back retract has started.
So now let's take a view up at the top of the rocket where we can see the clamp arms. They will begin to release the rocket at just about the midsection of the rocket, midway up. And we're also waiting for the NLM pole, which is coming up in just a few seconds. A final check with the NASA launch manager, Tim Dunn, by launch director Mike Taylor of SpaceX.
LD, NLM, countdown net.
LD.
The NASA Psyche team is go for launch.
Copy, go for launch.
Great news there. The spacecraft team is ready. NASA's launch
NY
team is
LOX
ready.
load is complete.
Yep, and there we heard a call out for a LOX load on one of the side boosters is complete as the team continues to fill the tanks and top them off, getting ready for launch. We should be hearing the other two side boosters finishing up along with stage
TY
2
LOX load
LOX
is
load
complete.
complete. There we heard the other side booster is complete with LOX load, Daryl.
These two side boosters, they'll be coming back today, so if you're here locally, you're going to get quite a show. Boosters 1064 and 1065, which have flown 3 previous missions, 2 DoD.
Center core LOX load is complete.
And 1 commercial mission. They'll be coming back about 7.5 minutes after liftoff. So look to the sky for that, especially that entry burn and landing burn. They'll make a sonic boom that you can't miss.
Yeah, absolutely. We are looking forward to those 2 boosters coming back. And as we talked earlier, that center core will be expendable. We will use all the propellants for Psyche today. And if you look at the launch vehicle, one of the unique things about that center core being brand new and expendable is you'll notice there's no grid fins or landing legs on that. And that is done by purpose to make sure we get the complete performance out of that center core for that trajectory that Jarmaine talked about to allow Psyche to perform its mission.
Always good to save some mass when you're flying a rocket to space. And those 2 side boosters, NASA has eyes for them for the Europa Clipper mission.
We do. Actually, the side boosters will be used on a...
Stage 2 LOX load is complete.
Stage 2 LOX load complete call out there. But those side boosters will be used on a Space Force mission later this year and or maybe early next year. And then we are looking to use those as our prime side boosters for the Europa Clipper mission in 2024.
And with that call out that stage 2 LOX is complete, the Falcon Heavy is now completely tanked with 2.8 million pounds of propellants. Getting into the final minutes of the countdown now. T-minus 1 minute and 37 seconds.
Gas launch closeouts.
So you heard there the ground gas closeouts, and see that burst of LOX coming off the side of the rocket there? That is emptying out the LOX line in the transporter erector or strongback. Getting down to the final minute now.
Falcon Heavy is in startup.
Good call out that the Falcon Heavy is in startup. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the Psyche spacecraft to deep space.
30 seconds. $15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange. M1D chamber pressure is nominal.
View there from the on-board camera on the booster. Beautiful shot there as it goes through the clouds.
Power and telemetry nominal.
Over here, Gerald, the power telemetry are nominal. We're also looking at the data for all 27 engines.
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic now.
Throttling down in preparation for max Q. A moment of peak mechanical stress on the rocket.
What will happen here
max
is
Q.
The side boosters will be at full power, and the center core will be at a reduced power to go through max Q to reduce the pressures on the structure of the launch vehicle.
Coming up in 30 seconds. We'll start getting ready to have those boosters cut off.
Vehicle's looking good, pitching down range. All telemetry looks really good so far, Daryl. So we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
All 27 engines of the Falcon Heavy putting down 5.1 million pounds of thrust. Standing by now for booster engine cutoff for those side boosters. The center core booster will continue on.
Booster engine cutoff. Side booster separation confirmed.
Great shot there of the side boosters coming off the rocket.
MVAC engine chill has started.
And there we start the chill on stage 2 as we get ready for MECO on the center core. Stage 2 will continue chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape. Next up is main engine cutoff of that center booster. After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside the
shutdown.
That was a shutdown.
Looking
main
now
engine
inside
cutoff.
the booster. There you have MECO.
Stage separation confirmed.
And there it goes. You're looking at the second stage in front of you, lighting up its
MVAC
MVAC
ignition.
engine. Split screen now on your right-hand side.
Center core FTS is saved. Bermuda.
Calling out the communication stations. What a beautiful shot there, while we had it, of stage 2.
Daryl, we continue to look at the side boosters.
Bearing separation confirmed.
Boost back has been completed, and they're in extended coast right now.
And there go the fairings. Revealing Psyche to the atmosphere. You can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel, Bob, is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes. We are going out over the Atlantic Ocean, heading south towards southern Africa. On the right-hand side, you see the glowing engine of the stage 2. We've got 2 cameras there On the left, we're tracking those boosters coming back down.
Yeah, we should see in about 20 seconds, we should see the booster entry burn, which is be the one engine on both side boosters.
Quite a clear image in space on the right-hand side. We've got clouds overhead on the left, but you can see at the center, we're tracking one of those boosters, also tracking the second stage, it looks like right there.
Yeah, all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for that booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side boosters are coming back.
Boosters entry burn startup.
And there we just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shut down.
And there we saw the booster entry burn on one and shut down. And there we see booster entry burn on the second side booster and shut down.
Next burn is the final landing burn. And for
PYNY FTS is saved.
And for folks who are in the area, you end up hearing that loud sonic boom, that thunderclap, just about the time they make landing.
Stage 2 is on a nominal trajectory.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
And that's a shot of the booster through a thin layer of clouds.
We hear the call out for transonic. Landing burn has started.
Here it comes.
I don't know, Daryl, but that sonic boom was great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking as both those boosters broke the sound barrier.
And we just heard booster landing confirmed, as we see on the screen, both landing zone 1 and 2. Everything looks great. And then the call out for
Stage 2 FTS is safe.
Psyche 1, Stage 2 engine cutoff. So, Daryl, this will put us into